Hi guys, welcome to the video. My name is Ben and today we're going to learn how to make a rainbow density column. Before we get started with the experiment, let's talk a little bit about what density is and how we calculate it. Density is a measure of how compact the mass of a substance is and is defined as the mass per unit volume of a liquid. With this in mind, the equation for density is as follows. We are going to need this equation throughout the experiment as well as the following simple conversion. We will be measuring out the volumes of our liquid in millilitres, but to calculate the density we need the volume in centimetres cubed. As we can see, 1 millilitre is the same as 1 centimetre cubed, so if we have 100 millilitres of a liquid, that would be the same as having 150 centimetres cubed of a liquid. These are the items that I have selected to complete my experiment. These are not exclusive as there are many different liquids that can be used for this. We're going to need some weighing scales, a calculator, a measuring jug, 4 plastic cups, 1 large glass jar, a turkey baster or similar implement, pancake syrup, washing up liquid, rinse aid and cooking oil. Before we start measuring out our liquid, we need to weigh an empty plastic cup as a reference. We can see from the image here that my empty plastic cup weighs 6 grams. Now we are going to measure out equal volumes of each of the 4 liquids that we have chosen. I've opted to measure out 150 millilitres of each liquid. Using the measuring jug, measure out 150 millilitres of syrup and pour it into one of the plastic cups. Repeat this for the remaining 3 liquids. You don't have to measure out 150 millilitres. I chose this because I'm confident that all of the liquid will fit into my jar without spilling over the top. So if you're going to measure out larger volumes, just make sure that your glass jar is big enough to hold all of the liquid. Now that we have measured out our equal volumes, we need to calculate their density. We'll start with the syrup. Using the scales, weigh the cup containing the syrup and record the mass. The mass of my syrup in the cup is 164 grams, but remember that we need to subtract the mass of the plastic cup, which we recorded earlier, to weigh 6 grams. 164 minus 6 is 158 grams of syrup. Now, using the density equation and the volume conversion from earlier, we can say that the mass of the syrup is equal to 158 grams and the volume of the syrup is equal to 150 centimetres cubed. Putting both of these values into the density equation gives us a density value of 1.05 grams per centimetres cubed. Just the same way as we did with the syrup, we need to weigh the cup with the washing up liquid in it using the scales. The mass of my cup with the washing up liquid in was 113 grams, so taking away the mass of the empty cup leaves 107 grams of washing up liquid. As we measured our equal volumes of all of the liquids at the start, we know that 150 millilitres of washing up liquid is the same as 150 centimetres cubed of washing up liquid, and now we have all of the components we need to calculate the density. Using the density equation, I've worked this out to be 0.713 grams per centimetres cubed. We will do the same with the rinse aid. The total mass of the rinse aid and the cup is 102 grams, therefore without the cup of the rinse aid weighs 96 grams. The volume is still 150 millilitres, which is equivalent to 150 centimetres cubed, and now we have all the components to calculate our density. Using the equation from earlier, we can calculate the density of rinse aid to be 0.64 grams per centimetres cubed. And finally, we need to do the same with our cooking oil. Now, the cooking oil inside the plastic cup weighs 0.97 grams, so taking away the mass of the empty plastic cup, we're left with 91 grams of cooking oil. We have 150 centimetres cubed of oil, so now we have all the components to calculate our density, and using the equation from earlier, we can compute this at 0.606 grams per centimetres cubed. Now it's time to add our liquid to the jar. The way we add these liquids is very important, as if done incorrectly, it could cause the density column to behave in an unexpected way. We need to add the most dense liquid first and the least dense liquid last. Using the calculations we did earlier, we can see that the most dense liquid is the pancake syrup, so we're going to add this first. I've already added the pancake syrup to my jar, as it takes quite a long time to pour out. But when adding the syrup, try your best to pour it into the centre of the bottom of the glass jar, and because any syrup on the side of the jar will interfere with the other layers. If it's taking a little while to trickle out, you can use a spoon to scrape out some of the syrup, but don't worry if you don't get all of it out. We only needed the equal volumes to work out the density. Now that the syrup layer is in our jar, it's important to let it settle before adding the next layer, which is going to be our washing up liquid. Just the same as we did before, it's important to try and pour the washing up liquid into the centre of the syrup layer. You'll see that initially the washing up liquid dips below the surface of the syrup layer, but then settles on top, creating a clear barrier between the two layers. Once both layers have settled, we can move on to the next layer. Adding the remaining layers requires a bit more care than before, as if they are added too fast, the new layer will mix with the layer below and create a strange murky solution. Grab the turkey baster and fill it up with the rinse aid, and then position the nozzle of the baster on the inside of the glass jar and then squeeze the top so that the rinse aid trickles down the inside of the glass jar. You should see it start to pool on top of the washing up liquid. Continue adding with the turkey baster until you have a large enough layer to see a clear boundary between the rinse aid and the washing up liquid. Once all layers have settled, we can move on. Our final task is to add the cooking oil. Using the same turkey baster, add the cooking oil in the same fashion as we did with the rinse aid. Continue adding the cooking oil until you are happy with your density column or you've reached the top of the jar. If all has gone to plan, then you should have your very own rainbow density column. Be careful not to shake it up too much, as if the layers mix, there's no getting them back. Here are a couple of ideas to try next. On the left are some other household items that you can use to complete this experiment. Make sure that you calculate the density of them first and add the most dense one at the bottom and the least dense at the top. Another idea, you can try to add the least dense liquid first and the most dense liquid last and see how the liquids interact with each other. On the right is the same experiment as we have just done, but this time the only liquid that we use is water. The difference in the water is there are different amounts of sugar dissolved into each of the waters, and it's important to colour these differently so that you can tell the difference. Add the water with the most sugar in first, and then the water with the least sugar in last, and see how the liquids interact with each other. Thank you for watching, guys. I hope you enjoyed learning how to make your very own density column. If you'd like to contact us with any questions or ideas for future videos, please don't hesitate to contact us on the email below.